Good morning, class. Today we are going to explore one of the most critical components of any robotic system, sensors. Think of sensors as the robot's sensory organs. Just like we humans rely on sight, hearing, touch, taste, and smell to interact with the world, robots rely on sensors to perceive their environment. Without sensors, a robot would not know what's happening around it. It would be blind, deaf, and unable to perform its tasks effectively. Example: a robotic vacuum uses proximity sensors to detect walls and furniture. An autonomous car uses cameras and LiDAR to navigate roads safely. Sensors are the primary input devices for robots. They collect data from the environment and feed it to the robot's control system, which then decides how the robot should act. This process is very similar to how humans process sensory information. Sense, 2, process, 3, act. Can anyone think of a situation where a robot without sensors would fail to perform its task? Sensor data is usually processed at different levels depending on its complexity and the robot's needs. Low-level processing, direct readings from sensors without much processing. Example: a temperature sensor reports 30 degrees Celsius. Mid-level processing, data is cleaned, filtered, or combined to make sense. Example: a distance sensor's readings are averaged to remove noise. High-level processing, data is interpreted to make decisions or trigger actions. Example: a robot detects an obstacle ahead and decides to turn left. Analogy for students: low level, what your eyes see. Mid-level, how your brain filters distractions. High level, deciding to move away from danger. Sensors can be classified in many ways, but one fundamental distinction is between passive and active sensors. Definition: sensors that do not emit energy. They only detect energy from the environment. Examples: light sensor detecting ambient light, microphone detecting sound, thermocouple detecting temperature. Key point: they rely entirely on existing signals. Definition: sensors that emit energy and then detect the reflected or returned signal. Examples: an ultrasonic sensor emits sound waves to measure distance. LiDAR emits laser pulses to detect objects. Radar in autonomous vehicles. Key point: they actively probe the environment to gather information. Picture this: a flashlight and a photodiode. Photodiode alone, passive. Flashlight plus photodiode, active. Sensors are the robot's sensory organs, providing the primary inputs for decision-making. Data from sensors is processed at different levels: low, mid, and high. Sensors are broadly classified into passive and active. Proper sensor selection is crucial for a robot to perform its intended function safely and effectively. Imagine designing a robot to help in a disaster zone. Which sensors would you use, passive or active, and why?